Good morning or even good afternoon, wherever you are. My name is Josh Benoit. I'm with the customer journey team here at Eplan USA. And welcome to our webcast. This webcast is talking about um, going from adoption to automation. And really, we know that you're going to have a lot of questions, and we invite you to ask those questions on here. You can send those in the chat. And also, this is being recorded, so you're going to get a recording of this tomorrow. It'll send it out to you, so don't worry about that. Also, information on the next webcast that we have, which, by the way, also features our presenter today, David Ridgel, who is, you've been with us a little while now. So, David, I'll let you give a little bit of information and background on you and how long you've been with us and really what you're doing here at ePlan USA right now.
Okay, thank you, Josh. Yes, I'm David Ridgel. I'm an application engineer here at ePlan for nearly 3 years at this point, so it certainly went by quick. And yes, I do trainings, consultings, implementations, technical support, everything in between. And like many people on the call, I come from a controls background in different industries, process control, discrete automation, working with all the different platforms out there. And recently, working with ePlan was new to me since starting here. Before that, I always used CAD tools and whatnot. So it's been a it's been a pleasure working and learning the entire ePlan platform for sure.
And and by the way, he is by far, excuse me, by far the most dapper person that we have working at ePlan USA. Always dressed up nice, always making the rest of us look bad because I mean, I'm just in my regular ePlan shirt and he's wearing a suit and tie on a webcast. Not bad, David.
Hey, I only do this for this webcast, Josh. Only for you.
Only for the webcast. Well, I'll let you go ahead and take it away. We talk about the adoption packages that we have, but really, how do you further yourself whenever you're done with that? How do you take that next step is really what we want to talk about today. And you're going to lead us through that process, really, and talk more about that.
Sure, absolutely. All right. If you'd like, we can go ahead and get started.
Yeah, go ahead, buddy. The
Feel
floor
free
is
to
yours.
Yes, and feel free to ask any questions along the way. I'm going to share my screen.
How many times did people use that saying before 2020? Let me go ahead and does everybody see my screen?
Yes, I think we're all just used to it by now. Okay. So we'd like to talk about, obviously the adopting ePlan and going from a more manual approach to an automated approach. So before we do the automation topics, maybe we can look at, some manual approaches first, just to kind of compare and contrast. So here we have a project in ePlan. Most people that work in ePlan are probably familiar with something like this, whether it's an NFPA or an IEC schematic, it really doesn't matter for this presentation. So obviously in the most basic way to design, we could use symbols, right? We can go and find a fuse from the Insert Center, and this pulls from our symbol libraries in the project, of course. And then hopefully our plot frame may have some invisible stuff like this to help us stay nice and symmetrical, right? And then you can place some contacts, motor, all the different things you may need, click and drag. You can go get a motor perhaps, power consumers, motor with PE, get your three-phase motor, right? And we have a place where to place it. Okay, so that is by far the most basic approach in ePlan, unless we were drawing lines and text. Hopefully we're not doing that. And there's a time and a place for this. Sometimes we may not know our part number and we need a symbol as sort of a placeholder. And you can of course add part numbers after the fact, go into your parts database, right, browse and find what you need. The problem with that is it's more of a two-step approach. So at the next level up, we would think about devices. In this case, right, I have to think about what symbol I need and then what device I want to place on top of it. The next level up, of course, is using devices because then we're thinking directly in terms of parts. If we know the part number that we need in our project, it's advantageous to use it in this way because it's one step instead of two or three, right? I can just take this part here, get the correct variant, and then place it. And then, of course, in the background, it has all the technical information that comes from the parts management, the technical characteristics, the current range, and whatnot, and any other properties we can display here in our normal display settings. So that's certainly more efficient, but the most efficient way, besides an automation tool, would be using macros. And this is important because these are the true building block of everything Eplan, right? So you could use symbol macros and part macros, which are tied to symbols. In this case, this is basically a symbol, but it can have some preset logic. For example, if we had some different logic that wasn't normal here, we can preset that up and save it as a macro. So that's another method. Another way is a window macro. Let's go to our window macro folder. And in this method, power supply. Okay, let's get the 480 volt stuff. In this method, we're really combining pieces of a circuit. So we're not placing individual components. We're placing a whole circuit or a portion of it. So I have this fuse disconnect, for example, and I can just place it to where it's designed to go. And in the background, so a macro will have two types of variations, right? It'll have a graphical variant. If you hit tab on the keyboard, you can toggle through that. An example of that, which we'll see in a second, is a motor circuit. Maybe it has one that's reversing or one that's direct as far as the contactors go. But we also have a non-graphical variation, what we call value sets. So this can drive any number of properties in the background. So in this case, I'm driving, when I select 60 amps, I'm driving the path function text, the disconnect, the fuses, and any number of properties that I need to control. We can select our disconnecting means. That, of course, has an effect on the part number. And then the handle, I'll go with the painted handle there. Okay, so in this case, I brought in an entire circuit, more or less. And I can repeat that process to build up my schematic. If we go back, we'll go to our motor circuits. When we look at this one, double click. Oops, I accidentally placed it. I'm just going to hit cancel. I'll delete that one later. And this one will have a graphical variation. So if I hit tab on the keyboard, you'll see some different options. So I can go with this reversing one here. And then you can select your horsepower. And as you can see here, we're driving 9 different properties from this value set, where you would normally have to go and think about changing all these, looking at data sheets. Okay, if it's this horsepower, I need this protection device. If the wire goes up to a certain gauge, we need to change the terminals. When you're setting up these value sets and these macros, you're thinking about that one time and not over and over. So yeah, you'll set up the table. In this case, this is actually public data available for everyone, and I'll show where that's at. But you set it up ahead of time, and then it's available for you in the future, right? That's the whole idea behind a macro. Go ahead and delete that and delete that. Of course, we can move it up, and we could renumber everything as well. Okay, so we renumbered our devices there. And these are very important because these macros are the building blocks for everything automation. So that's our next step, right? We want to take things we would normally do by hand and set some rules up where the schematics will be automatically generated, in other words. But without good macros, it's just, there's no way we can do that. We have to use these as our building blocks. So think of them as like Legos or whatever the case may be. We modularize our schematic where we can build up the entire project, basically. And what it looks like in setting it up, here we have the macro project where our automation configurator, what it's based on. All right, so we'll always need some power rails, for example. We may need it on the left or the right. We have these different variants. We may need some safety power contacts there. We may need a separate variant for our power when it ends. If you think about the end of the power rails, we don't need it to go onto the next page to nowhere. And then of course we need that on the right. We also need, of course, our PLC configurations. We'll have different configurations for a 4-slot chassis and the ControlLogix product line, 7-slot, and so on. So all this has been loaded into our configurator, and we have different rules to trigger when different devices are placed. So we can go ahead and switch over and look at that. The main automation product that we offer is called eBuild. This is the successor product of Cogeneer. Some people in the past probably have heard of Cogeneer. The difference is that this lives in the cloud instead of on premises, right? So we'll open up the eBuild project builder. And I'm just going to make it full screen here.
Hey, David, while you're doing that, a question real quick is, are these macros that you're using, are they out of the box, or are those ones
Yes.
that you created? They're out of the box. Okay.
I did make some modifications. For example, when you see this ending rail, for example, I had to make that in this, but that's very simple. You just take this one and delete those guys down there, right? I'll show you where you can find this. If you click on the Eplan engineering standard, it'll take you to this web page. And there's a lot more than just the macro projects here. If we look at what I'm currently working with, I'm working with this macro project for schematic blocks in the NFPA inch environment. That's what all these macros are based on, but of course I've made some modifications. We have an IEC version of that as well. And this is always a great starting point for a macro project, of course, because it's very structured. If you look here, it's all structured under these different categories. So everything's nice and organized, and then we can, of course, automatically generate the macros. There's also some other neat things here. You have a basic project for your normal schematic project. We look at, here it is, basic project for NFPA, so that'll be in the inch environment. If we open this up, you have the inch and the millimeter actually. There's also some good application examples and samples. So if you wanted to look at like best practice for ControlLogix and distributed point I/O, or the Siemens version of that, S7-1500 and ET200 SP, we have an example of that. If you wanted to have an exercise in trying out our smart production software, you can download that. So that's where I got that from. Let's flip back over to eBuild and let's create a new project. We first need to select our library. So in eBuild, you can have different configurators for different things. So I'm going to select the stacking system, and I'm going to select the most recent published version there, version 4. Okay, and I will create a new project. So you can either create a new one or add to an existing one. And we'll just call it eBuild demo 032625. We need to select the template. Just like if you were creating a new project by hand, you need to select a basic project. That's what this is asking for. So I have one specifically for this eBuild environment. Select that project, or that template, I should say, and then we'll select our storage location. Put it in this demos folder. And then we could select overwrite or do not overwrite. In this case, it's a new one, so either one would have the same result. And then we select our configurator. You can actually have multiple configurators in one library. In this case, I just have one complete config is what it's called. So we'll select that. General parameters, these could be different options to start. For example, I need some kind of incoming power. Do I want to use a fuse disconnect or a circuit breaker? When I select that, you may see some different options appear. So I need to select what amperage of my circuit breaker. Let's go with 100 amps. How do I want to disconnect this breaker? So we'll go with the painted 4-foot cable, for example, with the painted handle. Do I want to add the optional transformer? And for my 24-volt supply, what amperage do I want to select? What about the safety relay option? we can select this one here with the contactors and the reset with an expansion relay. For the 24-volt distribution, we can either select the single pole breaker or the electronic circuit protection. And then you have the general project properties that you would normally fill in by hand, the customer code and all that stuff, where they're located. Schaumburg, Illinois, and put that in. Okay, and then I'll just type eBuild demo. And then this is a really neat option. We can either generate the reports or not. For the first run, we'll do it without generating the reports, and then we'll come back and see how easily we can add them in, right? And then we have some different instantiated elements. So here, they're kind of separated because you don't just have a static quantity of one. You can select a different number, and we have a limit that's set up in the library. So for these VFDs, I've set a limit of 4. We'll go ahead and add 2 of those. And then we can select the different options. So I need to select what horsepower of the motor I'm controlling. 2 horsepower on the first one, for example, maybe 7.5 on the second one. And just like what we saw earlier when selecting the value set by hand, this will control many properties in the background, like the breaker size, the motor part number, terminal part numbers, etc. And then we'll select our motor starter circuits. We'll go ahead and select 7. And then we'll have the different options of direct or reversing, what horsepower. Go ahead and set those. I'll leave a couple as direct just to show the contrast, the difference. Set that as reversing, set this one as direct. Just picking some random values here. Okay. And then we'll create a PLC system. We'll create one system. Think of this as one rack more or less. I'll call it rack 40. And then we'll add our cards. We have up to 17 because this is a control logics chassis. So the largest rack you can buy is a 17 slot. So I'll select a 7. The neat thing is it'll automatically go to the next largest size. So if I were to choose 8, it would go with the 10 slot rack. So what type of card? We'll definitely need a CPU. I can either make it a safety or a standard. I'll go with the safety CPU. We'll place in a communication module there. We'll go with the 16 digital input, 16 digital output, 8 analog in, and then for this one you'll have different options. Do you want to use differential current or single-ended, or all the other options here? I'll go with single-ended current. And for the analog outputs, we have to select every channel. Do you want it to be current or voltage? I'll leave all of them as current. And then the last card will be a filler module, basically just a cover for a blank slot. We'll go ahead and generate this.
David, while you're generating that, let's talk about how the adoption implementation really helps prepare you for the automation that you're showing in this webcast.
Yeah, so when you're going through an adoption package or any Eplan consulting for that matter, you'll always be educated on the what's and whys and hows of a macro. How to set up a macro project, why do we need a macro project, what's the benefits of modularizing our schematic. So you'll typically create a pilot project, and then we extract your real circuits and real building blocks from that pilot project, so it actually applies to what you're trying to build, right? Because there is a misconception about the automated tools that we have. Oftentimes people think, oh, we have a lot of one-offs, we can't use it, but in reality, oftentimes their schematics will look and feel very similar. Obviously, there's different components, but we always have motor circuits, maybe we always have incoming distributed power, we have control voltage, safety circuits, and many times those things do look and feel the same. The components in the background may be different, but we can of course still utilize these automated tools. And as you can see, the project was created in seconds. We didn't generate all the reports, so all we have is the title page that was already included with the template. And then we have all of our schematics, right? Based on the different options we selected. So I selected that transformer. That of course gets placed. Remember, I selected a 100 amp breaker. and it actually renumbers everything. You'll notice all of the device tags are according to the NFPA standard, so we can certainly utilize that as well in the automated tools. We have our control voltage. We have our safety circuit based on those different options that we selected. Remember, we selected 2 VFDs. And then on the last one, you'll notice the power rails end. So these automated tools have a lot of logic in them. You can basically make a statement that says, if this is the last of whatever circuit, make sure it ends and doesn't continue, right? More of an if then else statement almost. And then same thing here. This is why I wanted to choose 7 motor starters, because you'll see when we get to the 7th one, it knows where to end. So you don't just have power rails on the bottom going to nowhere, right? You'd have to go and delete those later. It built our rack, and it automatically names all the slot numbers. You can see that based on its own intelligence. All we did was define the rack number 40. So it names everything rack 40, but the slot numbers are automatic. The neat thing about that is you can go ahead and do your addressing. So I can go to my PLC navigator. If we look at the navigator here, you'll see the rack configuration is already set up from eBuild. We didn't have to fill out any of that stuff. All you'd have to do is just address, make sure you're using the right standard. For this case, the Allen Bradley one is correct, and do your addressing, and you'll get all of your addresses, right, based on the rack and slot. And of course, you can jump over, and you'll see all those filled in here. Okay. Now we can we do it with the report. So let's flip back over to eBuild. This time we want to go back up and check that option to generate the reports. Go and check that and then hit generate again. You'll see it's doing all that. It says running script, right? That's what's happening in the background to run those reports and whatnot. Now you'll see, in addition to all the schematics, we have all of our reports. Of course, the title page was there to begin with, but now we have our table of contents. You have your bill of materials. We have our cable reports, cable diagrams, cable overviews, our connection list. This is stuff that basically leaves the panel. If you go inside the location, we'll see the same thing, but these are everything internal to the panel. Of course, our terminal reports, terminal diagrams, and whatnot. So all that was handled by the automated tool. And we can protect ourselves. So if you wanted to lock this project after the fact, you could open up your page properties, because every time something's automatically generated, it will say, hey, I've been generated from, it says Eplan Engineering Configurator, but that's the same technology that eBuild uses. So if I was to set this to no, that would actually protect it from eBuild overriding it again. So if you said, hey, this project's at a good enough state, I'm going to go ahead and do everything else by hand, you could set that to no, and it'll be protected from there. Because oftentimes you don't necessarily automate 100% of your project. You could automate 60, 70%. Get everything more or less kicked off, and then go fill everything else by hand, right? It's certainly still an efficient workflow. Any questions about any of that from your side?
We have a few questions, which are a little bit all over the place, that I can start asking if you like, because there's some really good ones in here.
Okay, fair enough.
Is there a way to create a macro which has its own part number?
Yeah, well, you can apply a macro to a part. If you open up your parts management, for example, every part has a number of macro properties. You have your standard macro. This one has always been there as long as I've heard about Eplan. This is your standard schematic macro, and then since version 2023, we have these different standard specific macros. where it's basically intelligent and knows, hey, I'm going into an IEC project, use this macro, but if I go to an NFPA inch, use that macro, right? So we don't need different parts for different standards. So in that way, yes, you can make a macro, apply it to a part, and then you're placing that by the part number. But a macro can also have several parts, like those window macros that we placed into our eBuild from eBuild. Everything here came from a macro, right? But in the background, there's several devices. You have this protection device here, VFD. See a part number there, of course, the cable, right? And then the terminals and whatnot, if we needed those. And all that's generated or controlled from those value sets. So just like when we place by hand, we had to select, hey, I want this amperage of a breaker or whatnot. Those same values and options get passed over to eBuild. So that's really all that's happening in the background. Everything is just triggered from a configurator instead of placing it by hand.
Another question is, how do you launch the insert center?
The insert center is always there. And if you don't see it, it could be that it's not pinned. If you see now, it's a flyout when I hit the pin button. But you can actually close it if you're in a schematic, right? If you have a 3D layout space or a 2D schematic open, the insert center is always there. Unless you're in an older version, if you're in something older than 2022, the insert center did not exist back then. So it was a different workflow to place things.
That's the big womp womp, right? This one is one that I think that I know the answer to because I saw you do it earlier. Are there NFPA macros in millimeter available too? And I think that you showed that whenever you went to the e-learning, not e-learnings, but you went to where you could find all of the macros.
Yes, that's a good question. There are macros available, but also one of the things about NFPA millimeter, it typically uses the same grid spacing that an IEC macro will use. So oftentimes it's so pretty easy just to flip and rotate the IEC macro to get it into an NFPA millimeter format, because those connection points will use that same spacing and whatnot.
Next question, can I have a macro in a macro? For instance, I have a
Yes.
macro that has a circuit configuration that is common among lots of HP sizes, but I want the CDP to only carry the wire size for the HP size. Wow, this is very, very detailed. So if you could kind of, talk through that.
You can certainly have macros inside of macros and then regenerate larger macros. A lot of macros there, but yes. So when you have a macro inside of a macro and then you regenerate it, those are called subordinate macros when they're replaced back into the schematic. And whether or not they get updated, there's a little bit of some rules there, but as long as it exists in the larger macro, when you regenerated it, that's how it's going to be placed, more or less. So yes, you can have many nestings of macros inside of macros. It's not a problem.
So speaking of macros, does it place the macros based on the XY of the macro? So like for instance, there will always be the same location on the page unless a variant places them elsewhere.
Yes, so that's a question about how eBuild knows where to place things. So there's a few different options. You can place it by coordinate. That's one option. You can also do a sequential placing. So if you have, let's say you're placing 8 motor circuits or something and you want them to be stacked on top of each other, in that case, it'll use the macro box dimensions and stack them one by one, right? And you can also just place on the original coordinates. So every macro, when it's created, think of it just like if you copied it. If I generate this motor from this position, let's pretend this is a macro project. When you go to place it, it's basically like copying and pasting, right? So when it hits XY enter, that same coordinate it was created on, that's where it's placed. So you can also use that same technique in eBuild, just say use the original position, and then it'll place it on the exact coordinate where it was created. Good question.
If you have any questions, by the way, you can leave them in the chat. We'll get to as many as we can for this. The next one, does the configurator only work with control logics? What about compact logics or micro 850? What about anything other than Allen Bradley?
It will work with whatever you set it up to work with, right? So this is something I built probably about a year ago. All those options are up to the person that programs it. Basically, you can use Siemens, Allen Bradley. As long as you have the macros, you can program them into your designer. So this is the other side of eBuild. This is the actual, what we call the designer. This is where you build the different rules. So if I go to my stacking system, this is what we just looked at, and this is kind of the back end of it. What do we need to build this? We need a macro project because that's how we add the macros in. On a basic level, you of course need a page, a blank page. That's what pretty much is always the first element. So here we have a page macro. It's always placed. You can preview it. Right, it's just a blank page. So that's what it looks like. In this page macro, we'll have different variables. So I made a variable for the plot frame because in the NFPA world, we need a few different options for 0 ladders, 1 ladder, or 2 ladders. So we have to consider that. In this case, I told it always use the 2 ladder one. That's what this one is. So we have to make sure we plug that in. And then we place the, this is the 24 volt distribution so that it has the rails first. Then it would place, there's a different option of the rails. So depending on what you need, right? So you'll see that there's this dependency. So it says if the DC distribution type equals electronic circuit protection, then it places this rail. If it's a single pole circuit protection, then it places the wider rails there. Because we don't want to place both of those. That wouldn't make sense. And then the same thing down here. Here's the actual circuitry of that. So here's your single pole option. Here's your electronic option. So we can see that there, right? And then you can get in some more complex ones like this PLC card configuration, for example. You'll see it has 26 different elements in it alone because we needed all the different options for all the different chassis sizes, all the different cards, and blah, 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 right? Of course, we need a page. We need an overview page. And then you have your 4-slot chassis, your 7-slot, and you'll see the different rules. So this says only place if it's the first instance and if the count of cards is lower than 4 or less than 8. Because if it goes up to 8, then we go to this one. If it's between 8 and 10, basically. Right? Because if you didn't have those rules, the Eplan is going to try to place racks on top of racks. And then you have just standard Eplan errors. You can't place a symbol on top of a symbol, right? Same thing in the automation tool. It's just doing things we normally do by hand, but much faster. Okay. If you'd like, we can also look at another automation tool that we have that'll also automate the 3D panel design as well. Unless you have another question, feel free to.
Yeah, I was going to ask you, are all these features available with eBuild Free?
Not eBuild Free. So eBuild Free is some examples that anyone can run. You can run through and check those examples out. It doesn't give you access to the designer, so you can't go in and make changes to it. But it does give you an idea of kind of the workflow of how the configurator works. Here you'll see several different libraries in the eBuild Free. I actually use some of these for my library. So this script examples, for example, that's how I included a script to renumber all the devices. And you'll see that there's a lot of those examples here. Renumber cables, renumber devices. You can make it export PDFs, back up the project, so on and so forth. And if we go back to the designer, we have what we call script typicals. These are my different scripts I use to, let's say, generate the reports, renumber the connections, and renumber the devices. And then when you download those examples from eBuild Free, it gives you a whole PDF or Eplan page that'll tell you how to actually set that up and what parameters you need and all that, right? So it's not magic. I didn't just wake up and know what to put in here. It was all described in that document, so it's pretty intuitive, right?
Now, if you create a page macro, can you build or create a new page with all the parameters updated without using eBuild?
Yeah, you can change after the fact for sure. So once you create any of these things, you can certainly make changes by hand. So I can come in here and change the description, incoming power 480 VAC. I could go place additional things if I wanted to place additional circuits. I can. I could go back, place a macro. Oops, let's change my grid. It's a little bit, there we go. Yeah, so you can always extend your project after the fact, and that is very common. Most people are doing a large percentage of the automation with the tool like that use these tools, but not 100%. So sometimes we'll do 70, 80, maybe 90% of the automation and then come back and complete everything else by hand for all the one-off stuff.
A question that we've gotten a couple of times now in the chat is, what's the difference between eBuild Free and eBuild Designer?
Right, so the paid version of eBuild gives you the designer and the project builder. It allows you to create your own configurations. For eBuild Free, you basically can just run these generic libraries that are here and just basically get a result in an ePlan project, right? So we have this electronic fuse. It'll tell you which template to use. So this one says use one of these templates, right? So I need to use the IEC basic template. Otherwise, the coordinates may not make sense. If you try to use an NFPA inch template on an NFPA millimeter library, that doesn't make sense, right? So we can create a new project, eBuild Free example, and it's told us to select this template, so that's what we'll do. Select your storage location, projects, demos, and go ahead and start that. Oh, here we have to select the option. So we have our configurator. Do we want to use this IEC page structure? We can apply our different structure identifiers. Circuit breaker DT, I'll just select, see if there's a note. Okay, I'll just put CB1. Trip curve, I'll go with the C. 10 amps. Power supply, page number 1. There's a lot of different options, so you could set your potential. These are actually, looks like our terminals, right? So XE1, XE2. Let's see, okay, that should be enough to actually generate it. Okay, so it generated that. We have our eBuild Free example. So it generates our power supply, and based on those different options that we plugged in, that's what we get, right? There's your title page and everything. Yeah, so that's basically what you get with eBuild Free. There's definitely some cool things in there for sure, but the full-blown designer and project builder, you would need the premium version of eBuild for that. And we also have another product available called the engineering configuration. This takes it to the next level and allows you to automate the 3D side of things as well. So if you like, we can take a look at that.
Yeah, please do.
I'm actually going to close ePlan because we don't need ePlan open for this. We could have it open, but we can just close it. So in this, basically the difference is we can automate different disciplines in addition to the 2D ePlan. We can automate 3D panels. We can create structured text documents if you wanted to have some PLC code written. It's really quite incredible all the things we can do. So in here we have this project that's created. In the background there's many rules and libraries and whatnot. And then we have this user interface that's custom built. That's one of the differences, is we build the UI. In that case we have more flexibility than we do in eBuild. So I can select one of my customers from this list, select our input voltage, how do we want to handle that, terminal or a plug. Do we want the options for a light and a fan? Do we want electronic protection or a regular breaker for the DC voltage? The different safety options, do we need an emergency stop or an indicator? How many axes do we want? So that will determine our motor circuits. I will select 4, select update extension points, basically make sure that we create all of the axes according to what I selected. And then we have our axis configuration, and we can change these different options. How do we want to control it? I'll just select inverter for that one. And that should be good. We'll go down and just save it. Hit save and then generate the project.
Should I add theme music right here?
Yeah, you can add like the Jeopardy theme, yeah.
Yeah, that'd be a good one.
Yeah, but in the background you'll see the progress. It's probably building the 3D right now is what it looks like. So yeah, there it goes. So just like anything else, when there's more data, it's going to take a little longer. But this one
Sure.
took a few seconds because there's 3D. It's literally building your 3D enclosure, placing all the rails and ducts. It's placing all the components, linking those to the 2D side and all that. You can see eBuild is still, ePlan remembers that eBuild was open, so it's still opening that. So I need to just make sure I close that once it initializes. Just close all that, close that. So this is the project that it created in the same way that we generated the reports from eBuild. It does the same thing. Very similar technology. Uses a script. It's actually easier to do this from EEC. There's just an option. You can just select true or false to generate these. Based on the different options we selected, it creates our schematic pages here. And what's the difference, right? This looks similar. Obviously, it's more of an IEC schematic, but the principle is the same. The difference is this also generated the 3D, and we can open the device navigator and see that. I see, okay, here's my function that's placed, but it also has the part placement. We have 2 part placements. So it places the main breaker, and then it also places our auxiliary contact right on top of it. So let's open up our layout space and have a look. So everything here was built by EEC. So it built all the rails and ducts, places our components, gives it the device tags, and of course that's what makes it link back to the 2D. And you can set these different offsets, for example. That's what happens here. That's why it's not right up against the end of the duct. I can even go over here and say open in EEC, and then it finds that device in EEC. So it's very easy to troubleshoot in that regard. And you have a lot more, flexibility in programming. For example, that's what this mate thing does here. What does all that mean? M4 are the different handles. So those are the leftmost handles, and then 25 is the millimeter offset. So I said, hey, take M4 is the left handle of this device. M4 is the left handle of that DIN rail. Give me an offset of 25 millimeters. But only if it's the first one, right? So let's look at this formula. If mc.mc equals mroot.mos blah 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 dot first, then list, basically do a 25 millimeter offset. Else, if it's not the first, do none. Right? So all this stuff may not mean anything, but it's basically asking for a relationship. Let's close this and go to the counterpart here. I can explain it a little bit better. Go to mechatronic. So if we look back here, we're at the mechatronic item. We'll look at that mate formula from this angle. So mc.mc means mc is 1 level up, mc.mc is 2 levels up. Now we're at axis. Now we're going to do a mechatronical object search for all the axis. So let's say we just did that alone. I'm going to comment this out real quick. Let's just have a look at that piece of it. just to illustrate the power of EC. So when I do this mechatronical object search, I'm basically asking, show me the objects in a collection. So I find four of these axes, right? That's these four. And basically the other component, I'm asking, is this the first one? If the axis I'm a part of, is it the first? If so, then do the 25 millimeter offset, else don't. That's basically what that does. So yeah, EC
Coming from,
certainly. Yeah, go ahead.
I was going to say, coming from a marketing background, this all makes a lot of sense.
Well, thankfully we have training for this sort of thing, right? So anyone can learn it.
Another question that we had in the chat is, do you have to wear a suit and tie in order to be this proficient with the software?
No, but I think it helps. You look good, you feel good, right? So no, just I always do these for these webcasts. I want to show up prepared.
You have any part of this, any more of this that you want to show us?
No, I think we covered all the bases. We don't.
Sure.
We could go really in depth, right? We could be here for hours and days talking about all the things automation, right?
And we do have a lot of questions that I think that what the best next step for those, because there's quite a few that will take a little bit more time than we have for the webcast. So what we're going to do is, and we do this a lot of times, is that we're going to reach out to you individually. We have your questions, and we'll reach out to you individually to get your answers to those questions, so that we can respond to you in person about those. I have all of these documented, and we'll definitely get back with you in order to get your questions answered, and really have that one-on-one time for things that you might want to know about. I do want to tell you that we have another webcast coming up with David, who does a fantastic job. It's going to be on April 23rd, and this time we're going to talk about modifying plot frames, which is something that we get a question about a lot. So we want you to get you help with achieving a well-organized schematic layout, tailor plot frames to your specific project needs, and ensure consistent formatting and organization. Give you that uniform look. So I'm going to drop this in the chat real quick. Let me give you the 1 second. This is the next one. If you look in the chat, you'll see that that's the GoToWebinar registration for April 23rd, our next one with David Ridgel. David, great job today. We appreciate it. Thanks to everyone that came on and asked questions and participated in this. Again, we will answer your questions. Don't worry about that. But also to let you know that you're going to get a copy of, or you're going to get the recording of this session tomorrow. So just know that you'll definitely get this. If you have a coworker that wasn't able to attend, they're also going to, if they registered, as long as you registered, or they registered, you will get a copy of this webcast. And we look forward to seeing you on the next one, talking about modifying plot frames with David. Again, David, thanks so much. We appreciate your time and efforts for this, and coming on and showing us about getting to that next phase with automation.
Absolutely. Thank you, everyone, for showing up. We had a good crowd today.
All right.
All
Have a
right.
great rest of your day, and we'll talk to you very soon. We
All right.
appreciate you.
Yep. Bye, Josh.